Can AI agent control a robot? In the series of videos, our mission is to make an XLeRobot, mobile open source household robot to be fully autonomous, self-conscious, and be able to do household tasks like cleaning totally by itself without any human help and presence. It's a thing. Just for some reason, no one did it before. My name is Grigory, and in that video we'll do the first steps. We'll implement the LLM agent to control a movement of our robot, to make him look through the camera, analyze his environment, and make decision to go that or another direction. But how can we actually connect the high-level LLM decisions with low-level wheels control? Also, somehow we need to give a commands to our robot to ask him to go to kitchen and bring us a yesterday pizza. So for that we also need to give him a microphone and activate some voice transcription. But even if we do it, how we can actually make the transcription to be activated only in the moment when we talk to the robot? That's the single thing I know for sure. We have a lot of work to do. What our robot will decide to do when we allow him to do anything he wants? How does he open the emergency? An effect when our AI starts doing something useful despite of never be designed to do it. And what really valuable present I prepared for that of you who have already assembled or will have assembled an XLeRobot. Welcome! In previous part of our video series, we assembled a mechanical part of our robot and set up simple keyboard teleoperation. You can check out how does we assemble the robot here, but in that part we're going to create an AI agent to control our robot. So, what I managed to do for now is to implement simple AI script here. I created an AI agent that controls our XLeRobot, which has a few simple tools. Controlling the movement of wheels of our XLeRobot. It has just tool to move forward, to turn right, turn left, and stop actually. So here in the text prompt I defined him a simple task to go forward and turn and stop. Let's see what will actually happen. Okay, and as we can see, our robot's moving forward, turning and, well, stopping. Oh, not stopping always. And what's interesting about that movements, as you can see, they are all controlled by AI. They are not pre-programmed by the code, but they are all controlled by our LLM commands. Every time he moves a little bit differently. Okay, so next thing we need to do with our AI agent is to provide him a visual feedback from the camera, to make our agent inside of the XLeRobot to be able not only to move, but also to see the world through its camera and to make next decision based on what camera sees. To do this, we need to gather an image from the camera and then provide it to LLM on every of its loop step. So I created here a simple capture image function that all it's doing is just capturing image from the camera and saving it to image.test.jpg file. I provided here the port of our camera, USB camera, and that way I'm doing the image. So let's run that feature and we have our image. Let's talk about how the search agent works. Do not get scared by the word agent, it's really simple in fact. Works exactly the same as the agent for internet research, but instead of the tools for read a site or check something in the Google, it has tools to move robot forward, turn robot right, left. At every iteration, our LLM receives the image from the robot camera. Based on that image makes a decision what actually to do in such situation, where to go, calls appropriate tool, as for example to move forward. Robot moves to new position, makes another photo, our agent again analyzes the new photo and again makes new decision, and so on and so. Very often in such projects, biggest problems are the very stupid ones. So now again I'm spending yet another day on things that should be solved like instantly. Actually I'm talking about choosing the AI framework to place behind of our agent inside of the robot. There's a lot of alternatives here in current days, like from very popular LangChain through Pydantic AI until to the small agents. But there's something with all that framework wrong. I can't find for now the framework that will be lightweight and functional simultaneously and will also have a good instrumentation. Finally, we ended up with LangChain because of the good instrumentation and convenience of using. But we used only the basic functionality of it to avoid that LangChain overcomplication and heaviness. Okay, and finally it looks like our robot started to work. Our agent inside of the robot started to work and execute its own commands. And we give to our agent a general task to approach a human that our agent needs to do in few iterations. In future, the same way we will give him a more complicated and useful tasks, as for example to bake me a coffee or bring me a sandwich from a kitchen. Okay, we made our robot to not execute things continuously, but to make action, think and make action again. And what he do now? He thinking. Oh, he going to you, Conrad.
Yeah, is it working?
Yes, his task now is to find a human and approach a human. So he actually doing it, thinking very long. Okay, so we enabled the full speed of that robot. He did only one tool call, not like previously the 2-1 simultaneously. The agent decided to make half meter forward and he did it actually. Yes, because he's in you and he wants to find a human in the room. I given him a tool to finish the task, but he forgot in using it, probably. And here we're making a debugging of our agent inside of the landsmith. We have all the history, all his iterations, what he's seen through his camera when coming closer to us, closer in every photo. As a lab core of our robot, we tried few models: GPT 4.1, GPT 5, Gemini 2.5 Pro, but finally we ended with Gemini Robotics R 1.5, the brand new model designed specially for the robotics applications. So actually all that new Google Robotics model is doing is moving our robot forward by 0.2 meters. So I provided robot with simple task to find exit of the room and exit through it. Let's check out what will happen if I run that model. Here we met the first complications in the robot control. Our robot wasn't able to turn precisely. It just turns by random angles instead of the exact angle he needs to turn to face a human. The problem is our robot just can't understand his positioning in the physical world. Imagine you need to guess the angle to the object or human based on the just single photo you see. Finally, we came with an idea. We augmented the photo with grid of angles before sending it to LLM. So now our agent can see the angles on the camera feed and can know exactly that to turn to that object, it needs to turn itself by 20 degrees. Okay, so now he has that grid added into the image. And this is how the robot sees the world now. He has that angles on the top of the grid. Every USB device you connect to Raspberry Pi, like robot arms or cameras, receives its unique name. Another annoying problem we met that Raspberry Pi constantly swapping that names. So imagine today you have your head camera received ID number 1 and your arm camera received ID number 2, but tomorrow after our Raspberry Pi is reboot, Our head camera receives ID number 2 and arm camera receives ID number 4. You can work on advanced control algorithms for robots when you have not solved such simple, stupid hardware problems. To solve the problem once and for always, we've written our own config. Have written the names of the camera, camera right, camera center, and arms, left and right.
Yeah, and basically the arms are hard-coded by the serial number of the modules, and the cameras are hard-coded by the the USB connectors, and that's how we recognize them.
Okay. For now, robot start to move by itself, wherever he wants, but can we make him to listen to our commands? And now we added the HUD, GPIO HUD to our Raspberry with microphones. So what we want to do now is to make our XLeRobot to be able to listen to voice commands. That will be another interesting challenge. Our soundboard we tested yesterday, that one unfortunately refused working with our Raspberry Pi. Probably because we have a newest Raspberry Pi 5 and the board is quite old and designed to work with all the Raspberry Pis like 3 and 4. So what we want to do now is just to switch to the usual microphone, which we will connect through the USB sound card. USB sound card will connect the microphone to our Raspberry Pi. That way we want to set up the sound on our XLeRobot to make him listen to our commands. For now it's okay, later you make better cable management. Trust me, I'm engineer. 1, 2, 3, 4, 1, 2, 3, 4. Trying to make that microphone work, and there's always some problems with microphone recordings. Very low level problems. It's hard to work with them, but we need to manage it. 1, 2, 3, 4, 1, 2, 3, 4. Trying to make the microphone work. As we can see, it partly works, but sound definitely is not perfect. Working entire day on the sound recording. It's like almost 9 o'clock now. We're all tired, but well, it feels like we're really close to making our sound finally work.
There is no tracking information for the current branch. I don't understand.
Yes, we're looking already like a zombie.
Non-object cannot be interpreted as an integer. Runtime error, failed to open input stream. Non-type object cannot be interpreted as an integer.
We made finally our microphone to work and be able to record sound. But problem is we can't afford to listen and transcribe all the time. It will be just token expensive. How can we make listening to be activated only in that particular moment when we're speaking to the robot to not burn the transcription tokens all the time? Okay, we have here a recording of the RMS or like level of sound our microphone hears. So you can see that when I'm talking loudly, that level increases, and when we're not talking at all or whispering, that level decreases. So all we need to do now to just find some silence threshold and use the threshold to activate the voice commands. Okay, so since we managed to make our transcription finally work, so we can tell something to our XLeRobot. Hello guy, how are you doing? Let's transcribe the text the most perfect way you even could. And you can see that text transcribed well! Woohoo! We are happy. Okay, starting trying to run our agent back on the XLeRobot, trying to assemble all things together, trying to do some movements. That guy been trying to find an exit of the room, hard-coded task. He's quite close, he approached the doors. Well, what will happen next? You can see what does the robot can see from his cameras here and tracing on every iteration. As you can see, he can see the wall only. But still he's not listening. We can't see any RMS printed here. Robot trying to maneuver in our room. Robot fighting with angry chair. Okay, he listening to our commands now. Robot! Go to that human. Go approach human. Robot, find and approach the human. And there was a moment when solving one issue causes another. Okay, that's interesting. So the problem is that our robot listens on motors.
Yeah. So basically, robot when it's moving, he hears its motors going and transcribe the audio of motors going brrr, and that's our issue.
Yes, and he thinks that task is there like well, it's not. So it's fun problem that the robot that has microphone and listen for that sounds as a human command to do, he also listens for the noise of own motors, and that makes him like treat noise as a new task to do. You can see here it's his transcription of what he seen. We have that sh here, which is actually a sound of the motor.
We are driving evidently Korean wheels because they are speaking Korean. Then in Russian, is that correct? Yeah. Then again in Russian. Then in Japanese. I don't know what language is that. Czech.
Poczujemy Slovak, I guess.
Slovak. oh, yeah. So it transcribes Polish.
It's already our word.
And then we stopped it. So yeah.
We solved the problem, at least partly, by enabling Raspberry Pi to refuse the sound if it's shorter than some amount of seconds. Usually, the voice commands are longer than the sound of the motor movement. So we have now fun household animal. He doing whatever he wants, going wherever he wants. For example, trying to find doors and going through them, but without arms working, he doesn't succeed. Unfortunately, it's fun to have such agent inside of your robot. Hey XLeRobot, your task is to find human. Find and approach a human. Yes, your task is to find human. Very good. He looking around. Oh, 180 degrees rotation. Oh, he sees me and trying to approach me. Oh, but he does not see under his legs. Find human in the room. Approach the human. Find human and approach human. There is something called in AI emergency, when our AI started doing something that it's not intended to do by creators. So just before you've seen how our robot been moving backward, while that robot has no ability to move backward. It has no tool to move backward, it has only tool to move forward. What our robot did, it came with an idea to call the tool move forward with a negative argument of meters. And he moved forward for negative argument, so in fact he moved backward. Now we asked the robot to exit the room. For some reason, he was completely unable to do it. Robot, find exit. Find exit of that room. Find exit and exit the room. Robot, exit the room. Exit the room. Robot, exit the room. Exit the room.
None.
Our robot is very close to exit the room through the doors. He almost managed it. Almost. You need to find exit and exit the room. Robot, exit the room. Robot, go out the room. Okay, so it seems we have some problem with the lag of our robot. According to our intuition and what we actually seen during his movement, we thought previously that every time he moves, turns for example, makes photo and sends that photo to LLM to predict next move. But actually it looks like the robot actually receives the previous, not the current photo to his LLM input, but previous one, and that's why he actually have like latent lagged photo, so not actual, not last one, but yet previous one. As you can just see, he wanted to exit the door, so he turned to look at the door And when he actually need to go forward to exit, he did some another movement, so he turned even more right, and then go forward, because then after he turned right, he just seen the door from the previous image, and that's why he just going forward like he did it just too late. And we need to find a reason and repair it. Okay, seems we found the solution. Problem being caused by OpenCV buffer, that while reading frames, it's been actually buffering them and been reading previous one from the camera buffer instead of newest one. Now we improve that problem, and the robot, I hope, will be working. Let's test it. Let's see if he will be able to do it. At least he's not going straight into the wall as previously. Yes! He finally did it! He did it! He did it!
Yes.
And after resolving the camera error, robot successfully managed to exit the room. Okay, here our next test. We have backpack here, robot is here. He looking at our backpack and he need to again approach backpack. Does he choose right way and go slight way down, or he will decide to go stairs and he will totally fall on the stairs? We will see it. So test have not passed, our robot going to fall on the stairs. Plan number 2. Okay, maybe it will work. Maybe he not understand that stairs are stairs when looking from the top, and we'll do it different way. We will try to go from bottom up, because from that direction it's much better because the stairs are stairs. It looks he finally found a ramp and tried to use a ramp. Wow. Looks like he finally going to use a ramp. No, he didn't. Test of ramp failed. Next test, searching the human in the corridor. Will robot understand where the human is? We will see. So find the human, approach human. Sometimes we mistakes right and left. He coming to me? Good robot, good robot. Yeah, he managed to find me in the corridor. The next task for our robot we want to give him is to find a backpack inside of the building. Here. We will place robot around the corner. Let's check if he will be able to find it. Unfortunately, robot hit a wall in the test. Literally. He been constantly hitting at walls. Okay, so it's time to give him some simpler task. Let's make that backpack in his visual range, not around the corner. We will succeed this time or fail like previously, but before we proceed to the test, there's a surprise I promised you. We open sourced all the code we have written in that video and will write in the next videos of the series. Because Grigory here, it's not just to talk to you or to show you nice pictures of the robots. Grigory gives you a concrete, measurable value in the form of the control algorithms you can already today implement on your robot. First link in the description.
We go and explore them.
Robot, turn around! Turn around! Oh, listens to me, he listens to me. Okay, first success. Small but success. We're happy. So our robot just approached the backpack. Well, it's been straight away here, but he still approached the backpack. We are starting to be happy. In that video, we implemented a simple AI engine to control our robot, which is able to make own decisions, write wherever he wants, and listen to human commands. And it even works sometimes. Yes, I know he still mismatches right and left, does not understand his own body size, and just makes stupid decisions. But that's all the problems we're going to improve in the next videos. Stop! In next video we need to activate his arms to do a manipulation tasks and bring an object using VLAs, Vision Action Language Models. We want our robot not to just be able to transport an object like documents on his own body, but also be able to grab the documents from a table, transport them and give the documents to you, which will be a real office task our robot can do. Link to the next video is here if it's available already. If not, I encourage you to get familiar with VLAs, Vision Language Action Models in meanwhile by watching my previous video where I run and compare such models. And that's all from my side. Thank you for watching the video till the end, and I will really appreciate if you like the video and subscribe to the channel. It will really help my small channel to grow and motivate us to produce more, better videos for you and develop more advanced robot control algorithms. Cheers!